Today we're going to find domain and range of a function. So the first thing you should do is add to your table of contents on line P, add domain and range, page 34, to line P. And then write today's learning target at the tippy top of page 34. Today's target is I can find the domain and range of a function or a relation. So the first thing we're going to do is add two definitions to the front of our foldable. So the first definition we're going to add is domain. Domain is X, all your X's, so it's the set of all possible inputs. And then add range, which are your Y's, the set of all possible outputs. Continue the video after you write your definitions. When you're done with your definitions, on the inside of your foldable, we're going to do some examples of different representations. So the first example we're going to do is a numeric representation, which is a table. So domain are the inputs, are all our possible X values. Remember, they are the independent variables and they're the first numbers of the ordered pair. So in a table, they're going to be on the left, or if you have a sideways table, they're going to be at the top. So all we have to do is list the items in the domain that we see in the table. So we're going to just write D for domain. We're going to use set notation, so we're going to use the curly brackets. And we're just going to simply list all of the items of the domain. We're going to put them in order from least to greatest, and we're not going to write repeats. So we have -4, comma, -2, comma, 0, comma, and 2. And we're going to close our curly brackets. So that is our set, our domain. The range values are the outputs, all the possible Y values. We know that that's the dependent variable, and it's going to be the second number of the ordered pair. So our range of this relation is going to be all of the numbers that we see listed here in order from least to greatest and not writing any repeats. So we have -12, -6, 0, and 6. Simple as that. Let's go ahead and try another example on our sideways table. So let's first do our domain. So domain are our inputs, all our possible X values. So we have -4, -2, 0, 2, and 4. Our range are all our possible Y values, our outputs. And if we take a look at our table, at our Y's, it looks like we only have one number in that set. We do not have to write repeats, so we just write the number 2. That is the only item in our range. Okay, we're going to move on to ordered pairs. So when we have ordered pairs, the domain are the inputs, which are the first numbers of the ordered pairs. So when we take a look at this, we have our domain. It's going to be the first item in our ordered pairs. Those are our X's, our inputs. So we're going to put them in order from least to greatest, not listing any repeats. And those are in order for us. So we have -1, 0, 2, 3, 4. And that's it. Then we have our range. Our range are our second items. So our range, we're going to list them in order from least to greatest, not listing any repeats. So it looks like we only have -3, 0, and 5. That's all the items of our range. Okay, let's move on to the next representation, which is an A, algebraic. We have an equation. So the directions say create a table by selecting inputs and evaluating for outputs. The domain is all possible inputs, not just the ones we chose, and the range is all possible outputs from every possible input we could have chosen. So that's going to be a lot of numbers we can plug into this. So let's start out by making a table. Now you don't have a lot of room, so I recommend, you only have this little skinny space, so I recommend maybe you turn your paper sideways and you can make a baby XY table this way, sideways. Okay, so let's think about plugging in some numbers. So remember, it's going to be all possible inputs. So it could be any kind of numbers we want to pick. So I'm going to go ahead and draw my table up and down so that you can see it a little bit better. So we have X, Y. So what kind of X's can we pick? We could probably pick, let's just pick 1. That's nice and easy to plug in. So we're going to plug in 1 for X. So that means Y equals 4 times 1 minus 5. So Y equals 4 times 1 minus 5. So 4 times 1 is 4, minus 5 is -1. There's one of our ordered pairs we can get out of this equation. Let's try another one. Would it be okay if we picked negative numbers? Let's try -2. So we're going to be plugging a -2 in for X right here. So we're going to plug in a -2 this time. So I'm putting in a -2. Okay, so we have Y equals 4 times -2, that's -8, minus 5 is -13. Okay, do you think it would be okay if we picked fractions? Let's try a fraction. What if we picked 1/4? So we're going to substitute in a 1/4 for X. So we're putting in a 1/4 for X. So 1/4. So we would have 4 times 1/4. That is 1. Take away 5 is -4. Okay, do you think we could put decimals in? Let's see. Do you think that would be okay? Let's put in 0. What do we want to put in? 0.5. So 0.5, let's try that, 0.5. So we're going to plug in a 0.5, 0.5. So that is 4 times 0.5, that's 2. Take away 5, that's -3. Okay, so remember in our definition it said that we want to, our domain is going to be all possible inputs. So did it matter if we put in whole numbers or negatives or fractions or decimals? No, it did not. So that means our domain could be any number we wanted to plug in. Positives, negatives, fractions, decimals. So our domain is actually all real numbers. So we just write all real numbers because any number could have been plugged in. All real numbers. Now our range, so let's think about that. Our range, if we were to be plugging in any real numbers we wanted, we probably could have gotten any kind of numbers over here as our range, right? So if you can put in all real numbers and times it by 4 and subtract 5, you're going to get all real numbers back out of your function. So that means our range is going to also be all real numbers, because it is possible to plug in decimals, fractions, and negatives and get out